FastMCP 2 implements a distributed task scheduling system through the MCP background task protocol, allowing asynchronous execution of operations with configurable polling intervals and execution modes. This system enables clients to start tasks, track progress, and retrieve results through standard MCP interfaces, with FastMCP handling the coordination at the protocol level. In the upcoming code, we'll examine how to configure task execution behavior using TaskConfig, specifically focusing on customizing polling intervals for different types of tasks. The example demonstrates setting up a FastMCP server with two tasks that have distinct polling intervals, one optimized for quick completion and another for longer-running operations.
From DataTime, import time delta. From FastMCP, import FastMCP. From FastMCP server tasks, import TaskConfig. MCP equals FastMCP my server. Hash poll every 2 seconds for a fast completing task. At MCP, tool task equals task config mode equals optional, poll interval equals time delta scans equals 2. Async def quick task SDR. Return done quickly. Hash poll every 30 seconds for a long-running task. At MCP, tool task equals task config mode equals optional, poll interval equals time delta scans equals 30. Async def slow task SDR. Return eventually done.
This code demonstrates how to customize polling intervals for background task execution in FastMCP 2. The pattern uses TaskConfig with poll interval to optimize client-server communication based on expected task duration. For quick task, a 2-second interval provides rapid feedback for fast operations, while slow task uses a 30-second interval to reduce server load during long-running processes. The approach balances responsiveness and efficiency by letting developers specify appropriate polling frequencies per task. Shorter intervals improve user experience for quick tasks but increase server load, while longer intervals reduce overhead but delay status updates. This granular control is particularly valuable in distributed systems where task durations vary significantly. Both tasks use mode equals optional, meaning they can execute either synchronously or as background tasks depending on client requests. This flexibility, combined with custom polling intervals, allows servers to handle diverse workloads efficiently while maintaining good client responsiveness across different operation types. Let's break it down.
From DataTime, import time delta.
Imports the time delta class from Python's DataTime module for time duration calculations and manipulations.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol MCP servers. The imported class will be used to create FastMCP server instances with configurable identifiers.
From FastMCP server tasks, import TaskConfig.
Imports the TaskConfig class from the FastMCP server tasks module, which provides configuration options for task execution in FastMCP.
MCP equals FastMCP my server.
Creates an instance of FastMCP with the server identifier, myServer. The string parameter serves as a label for the server that will appear in MCP protocol handshakes to help clients identify this specific server instance. This line initializes the FastMCP component, but doesn't configure any operational behavior or modes.
Hash poll every 2 seconds for a fast completing task. At MCP, tool task equals task config mode equals optional, poll interval equals time delta scans equals 2. Async def quick task SDR.
Decorates the quick task function as an MCP tool with optional task mode and a 2-second polling interval. The decorator specifies that this tool can run either synchronously or as a background task. And when executed asynchronously, clients will poll for status updates every 2 seconds instead of the default 5-second interval. The function is registered with FastMCP's tool system, automatically using its name and return type annotation for the tool definition.
Return done quickly.
Returns the string literal done quickly as the result of the function execution.
Hash poll every 30 seconds for a long-running task. At MCP, tool task equals task config mode equals optional, poll interval equals time delta scans equals 30. Async def slow task SDR.
Decorates the slow task function as an MCP tool with optional task mode and a 30-second polling interval. The decorator configures the tool to execute synchronously when called without a task parameter, or as a background task when called with a task parameter. Clients polling for task status will be instructed to check back every 30 seconds.
Return eventually done.
Returns the string literal, eventually done, as the result of the function execution. FastMCP2's distributed task scheduling shines through its granular control over polling intervals, letting you optimize client-server communication based on task characteristics. By configuring TaskConfig with custom poll interval values, you balance responsiveness and server load. Short intervals like 2 seconds keep users informed during quick operations, while longer 30-second intervals reduce overhead for slow tasks. Both examples use mode equals optional, giving clients flexibility to run tasks synchronously or asynchronously. This pattern of per-task polling configuration, combined with optional execution modes, creates an adaptive system that handles diverse workloads efficiently while maintaining good user experience across different operation types. The key insight is that FastMCP puts you in control of the polling cadence, allowing protocol-level optimizations that scale with your application's specific needs.
The server shouts, "Check back now," while the task slowly sips coffee, ignoring the urgency.